The Hubble telescope took these pictures of the bullseye galaxy.
It is more than twice as big as the Milky Way.
Its rings were formed when a blue dwarf galaxy crashed through its center 50 million years ago.
And Friday marks 30 years since the launch of the famed Hubble Space Telescope. Hubble blasted off on April 24, 1990.
Across the immense, silent reaches of the universe, seemingly empty and untouched, extraordinary processes are constantly unfolding. With every sweep of its lenses, the Hubble Space Telescope brings these events into focus, transforming the remote and unimaginable into something we can see, ponder, and attempt to understand. Recently, Hubble has provided us with another remarkable vision, a dazzling fireworks show at the center of a galactic collision, a scene that combines complexity, beauty, and insight into cosmic transformation. Imagine looking not at human-made fireworks, but at a spectacle on an entirely different scale. When galaxies interact, their constituent billions of stars and sprawling clouds of gas fall under the influence of massive gravitational forces, unleashing tumultuous waves of energy. Hubble's gaze can catch this process mid-unfolding, capturing spirals of star formation, bursts of color, and patterns that suggest the universe is far more dynamic than the quiet darkness suggests. Among the images recently shared by NASA is a detailed view of the spiral galaxy NGC 2835, located approximately 35 million light-years away. This face-on perspective, celebrated under the hashtag Hubble Friday tag, shows the galaxy shining brilliantly, its features crisply delineated by Hubble's keen optics. But this image is more than an aesthetically pleasing snapshot. It invites us to delve into the processes that shape galaxies and perhaps even foreshadow the fate of our own Milky Way. The fireworks on display are the visible evidence of star-forming regions, energetic activity, and the effects of galactic interactions. But to really appreciate what these cosmic fireworks signify, it's essential to look past the metaphor and into the scientific story, how such scenes are formed, what they mean for the evolution of galaxies, and what they can reveal about the history and destiny of our universe. The galactic stage, NGC 2835. To understand this cosmic event in sharper detail, let us consider the setting, NGC 2835 itself. This spiral galaxy has long captured the attention of astronomers with its well-defined arms, rich star clusters, and areas of active star formation. At a distance of 35 million light-years, it is a remarkable testament to Hubble's power that we can examine its structure in such detail. NGC 2835 displays prominent spiral arms stretching outward, dust lanes snaking between brilliant clusters, and glowing nebulae marking intersections of gas and new stars. The face-on vantage reveals a luminous central core, highlighted by rings and filaments that radiate energy in all directions. In every swirl, there are blue young stars, pink clouds of ionized hydrogen, cradles for those stars, and traces of older, redder stars farther out. The spiral form of such galaxies results not just from random organization, but from the gravitational interplay of their constituents. Density waves within these galaxies compress gas and dust as they orbit, sparking generations of new stars. This cycle of birth, life, and explosive death reshapes the galaxy ever so gradually. Much of this occurs in relative stability, yet subtle distortions, slightly warped arms, knots of gas, or twisted dust sometimes betray the lingering evidence of past or ongoing interactions with other galaxies. NGC 2835's luminous heart and subtle asymmetries are evidence that even galaxies on their own can be transformed by encounters and gravitational influences from their environment. Though it is not one of the most violently disturbed systems, its Hubble portrait reminds us that no galaxy is truly untouched by its cosmic neighborhood. Before we continue, don't forget to subscribe to the channel so you never miss the latest cosmic discoveries and deep space insights. The energy of a galactic interaction. But what generates the vivid fireworks seen by Hubble, bursts of color, arcs of star formation, and the intense shine at a galaxy's center? The answer is rooted in the dynamics of galactic interactions. When two galaxies approach each other, their gravitational fields disrupt the structure and content of both. While the vast majority of stars pass by unscathed because of the enormous distances between them, the clouds of cold gas and dust are shocked and compressed. This process does not happen through instantaneous crashes like colliding billiard balls, but through long-term tidal interactions. These interactions stretch and distort spiral arms, trigger compressions of interstellar gas, and send waves of material inward toward the galactic centers. Regions where clouds are compressed experience a spike in star formation. The motive of these new stars live fast, burn bright, and die young, exploding in supernovae that dramatically outshine their surroundings. Such bursts of star creation and destruction shine especially bright in the ultraviolet and visible wavelengths Hubble is designed to observe. They produce the spectacular pattern of brilliance, often compared to cosmic fireworks, vast collections of stars igniting nearly in unison and spreading their light across the galaxy. In some images, the view is so direct and clear that the event seems frozen in time, a record of both chaos and creativity. This process lays bare a fundamental principle of galactic evolution. Disruption breeds creation. A collision or close interaction with another galaxy may temporarily destabilize ordered structures, but it also drives the processes that reshape and revitalize galaxies. Turbulent gas clouds are converted into new generations of stars, some of which, in death, seed space with elements vital for future systems. Understanding galaxy collisions, the mechanics behind the beauty. Delving deeper, it's important to clarify how galaxy collisions actually occur and what they produce. As galaxies merge or pass near each other, vast gravitational tides generate immense forces that stretch, compress, and ultimately blend the stars, gas, and dust involved. Yet because galaxies are mostly empty space, actual star-to-star collisions remain extremely rare. Instead, the significant action occurs in dense gas clouds. As they encounter one another, these clouds collide, shock, and compress to form new stars, often at rates many times higher than normal. Such starbursts may also trigger chains of further events, regions of intense radiation, the rapid formation and death of massive stars, and recurring supernovae that energize the surrounding interstellar medium. Hubble's crystal-clear imaging captures these phenomena. Brilliant patches of blue from newborn massive stars, pink hues from glowing nebulae, and arcs and streams trailing away from warped galactic disks. The visible signatures of a galaxy merger or close encounter can persist for hundreds of millions of years, leaving behind tidal tails or ring-like structures as records of these events. Some of the most famous examples of galactic collisions show two distinct nuclei embedded in a cloud of disorganized starlight, a sign that the final merger is underway, but not yet complete. As time progresses, the galaxies may finally merge their shapes, blending their stars and gas into a single, more massive system. Depending on the circumstances, the result may be a giant spiral, or more often, a smooth, elliptical galaxy. Throughout this process, destruction and construction go hand in hand. Stars are tossed to new orbits, spiral arms can be stretched or broken, and gas may be shock-heated or thrown out into deep space. Yet out of this seeming chaos, galaxies grow, evolve, and sometimes birth new planetary systems made from enriched material previously locked in stars that have now died and exploded. Galactic mergers as engines of change. Galaxy mergers are not a rare phenomenon. Rather, they play a pivotal role in the ongoing evolution and growth of galaxies across cosmic time. Evidence suggests that most large galaxies have grown through a series of mergers, ranging from minor interactions with smaller companions to major collisions with equals. Each of these events contributes to the overall architecture and star content of the galaxy that results. For example, the galaxy known as NGC 5256 is currently experiencing a merger, with Hubble's imagery showing two distinct nuclei, a swirl of colors, and a wealth of energetic starburst regions. These scenes are more than beautiful. They serve as records, letting astronomers piece together the history of how galaxies literally build themselves out of chaos. Similarly, other distant galaxies display ripple patterns, rings, or tidal tails that all point to some prior encounter. One notable case is the so-called bullseye galaxy, a giant system over twice the size of the Milky Way, ringed by a series of 9 concentric star clusters. These waves are likely the result of another galaxy plunging through its core, sending out ripples that compress gas and trigger new generations of stars as they move outward. Each ring tells a layer of the galaxy's tumultuous past, a fossil record of cosmic interactions. These observations are supported by sophisticated computer simulations that make sense of the structures observed. By comparing real images with models, astronomers can infer the sequence of encounters, the dynamics of the interactions, and the likely future evolution of the galaxies involved. The future of the Milky Way. Will we experience a collision? With galaxies colliding and merging throughout the observable universe, a natural question arises. Is our own Milky Way destined for such an event? For a long time, astronomers assumed that the Milky Way and its nearest large neighbor, the Andromeda galaxy, were on an inevitable collision course. With only about 2.5 million light-years between them and both moving toward each other, the expectation was for a slow but certain merger several billion years in the future. However, improved observations, including precise measurements from the Hubble and Gaia space telescopes, have introduced new uncertainty to this picture. Thanks to refined data about the relative motions and trajectories of both galaxies, astronomers now estimate that the odds of a direct collision are approximately even, about a 50-50 chance. The galaxies might merge, or they could pass by each other closely and continue on slightly altered courses. It's also possible the interaction could take a far more complex path, involving smaller galaxies that orbit both the Milky Way and Andromeda. What is certain is that whether through collision or near miss, the gravitational interplay between these giants will reshape their structures over time. Streams of stars and gas may be exchanged, spiral arms may be pulled and distorted, and if a merger does occur, the combined galaxy may ultimately take on an entirely new form. While these effects are not likely to become visible for billions of years, scenes similar to the spectacular moments captured by Hubble elsewhere in the universe will eventually play out in our cosmic neighborhood. Other galactic fireworks, the Bullseye Galaxy and NGC 5256. Beyond NGC 2835, Hubble's catalog is filled with images that highlight different stages and types of galactic interaction. The Bullseye Galaxy, an enormous system featuring a sequence of 9 well-defined rings, is a striking example. These rings almost certainly originated when another galaxy plunged through its center, driving regular, expanding waves of star formation outward from the impact site. Each ring acts as a timestamp, measuring the aftermath of the encounter and its effect on the galaxy's structure and stellar population. Another striking example is NGC 5256, where Hubble's photograph reveals not one, but 2 galactic cores embedded in swirls of gas and young stars. The scene is a chaotic blend of color and form, featuring starbursts, intense central light, and trails of disturbed material. Astronomers study these objects to better understand the physical mechanisms driving gas inflow, star formation, and black hole growth triggered by galactic mergers. Such systems demonstrate the full spectrum of galactic transformation. Some emerge as larger, brighter spirals, their arms rich with new stars. Others ultimately become featureless ellipticals, their gas exhausted in spectacular but short-lived episodes of star formation during and just after the collision. By following these cases across the universe, astronomers reconstruct the grand tapestry of galactic growth and change that continues to this day. Supernovae, stellar endings in the midst of chaos. Galactic collisions not only reshape entire systems, they dramatically affect individual stars as well. One of the most vivid consequences is the increased frequency of supernovae, the explosive deaths of massive stars. With the elevated rate of new star formation during encounters, more massive stars are created. These stars live only a few million years before exhausting their fuel and detonating in fiery supernova explosions. Hubble's sensitive imaging has captured supernova with striking clarity, even in distant galaxies. One such instance involved spiral galaxy NGC 2525, where Hubble observed a massive star erupting in a supernova, visible from across millions of light-years. These events not only serve as beacons that allow astronomers to study the host galaxies, but also play a key role in dispersing heavy elements created within the stars out into the surrounding gas. This material ultimately contributes to the birth of new stars, planets, and in some regions, perhaps life. The link between galactic mergers and supernova rates is well established. The more intense the starburst triggered during the collision, the higher the number of brief-lived massive stars, and thus the more frequent the supernovae. Observing the frequency, brightness, and locations of these explosions lets astronomers map how efficiently collisions stimulate stellar birth and death within these changing galaxies. Tools for discovery: the role of Hubble's observations. Much of our understanding of these phenomena relies on the data collected by the Hubble Space Telescope. Its position above Earth's atmosphere allows astronomers to observe the faintest and sharpest details in visible, ultraviolet, and infrared light. Every new image offers not only aesthetic value, but a trove of scientific clues about the life cycles of galaxies. These observations, however, do not stand alone. They are combined with data from other telescopes, including Gaia, which specializes in measuring the positions and motions of stars, along with computer models that simulate galactic dynamics over billions of years. Together, these tools let researchers reconstruct the sequence of events in past collisions and predict the likely fates of galaxies billions of years into the future. Patterns such as rings, arcs, and tidal tails are more than adornments. They encode physical information about the forces at work, the timing of events, and the nature of the objects involved. By interpreting these features, astronomers continue to deepen our understanding of galactic history and the larger processes shaping the universe. After the collision, remnants, and new beginnings. Though the spectacle of a merging or colliding galaxy can appear tumultuous, the aftermath is often surprisingly serene. Over time, the scattered streams of stars settle into new orbits, eventually smoothing into a unified system. Depending on the specifics, relative size, velocity, and composition, the final product may be a more massive spiral, or commonly an elliptical galaxy dominated by older stars. During the process, much of the gas that fueled star formation is either consumed or flung out into intergalactic space. Some of the elements, forged in supernovae, carbon, oxygen, iron, and more, are dispersed, enriching the raw material available for future star and planet formation. Thus, galaxy collisions serve as engines for mixing and redistribution, critical to the chemical diversity seen throughout the universe. In some mergers, the supermassive black holes at each galaxy's center may also spiral inward, eventually merging themselves. While this process is invisible to Hubble's eyes, it is a candidate for producing powerful gravitational waves, ripples in space-time detectable by dedicated instruments. The aftermath of such a merger can leave a single, larger black hole at the heart of the new galaxy. Ultimately, while collisions may erase the old shapes of galaxies, they create the conditions necessary for new generations of stars and planets. The violence of the process seeds possibility. Future worlds are born from the remnants of ancient explosions and stellar alchemy. Reflections in starlight. In contemplating the images delivered by the Hubble Space Telescope, one comes to appreciate the universe as a place of constant change and creativity, where destruction and rebirth are intertwined. Whether observing the elegant symmetry of NGC 2835, the dramatic rings of the bullseye galaxy, or the riotous center of NGC 5256, each snapshot reveals a universe in motion, shaped by the forces of gravity, time, and the unending cycle of creation and destruction. These spectacular cosmic fireworks are not rare exceptions, but an ongoing process by which the universe renews and transforms itself. Each interaction, whether quiet or tumultuous, adds to the structure and complexity of the galaxies that inhabit the cosmic tapestry. The heavy elements forged in the centers of stars and scattered by supernovae become the building blocks for new stars, planets, and eventually life. Looking forward, we can be certain that change is constant. Whether the Milky Way eventually collides with Andromeda or continues serenely, our galaxy too is a participant in the cosmic story of growth through encounter. With telescopes like Hubble making each chapter visible, we are privileged to witness and begin to understand these grand events, bringing the universe's distant wonders ever closer to home. So, when you next look up at the stars, remember that each point of light represents not just a distant sun, but a survivor, a participant, or a product of the ancient drama that is still unfolding. Through Hubble's watchful eye and the patient work of scientists, the secrets of these cosmic fireworks come into ever sharper focus, reminders that our universe thrives on change and surprise, and that we are all in some way connected to these epic journeys of destruction and renewal across space.